Mastering defect prevention techniques. We're crippled by the defects we ignore. Which types of defects are most prevalent in our organization, and what measures do we currently take to identify, analyze, and rectify them in order to achieve operational excellence? As I stepped into the role of leading a team of engineers at a manufacturing plant, I knew that defect prevention was key to achieving operational excellence. The plant had a reputation for producing high-quality products, but I sensed that there was room for improvement. I decided to dive in and understand the root causes of defects and what measures we could take to prevent them. My first step was to get familiar with the production process. I spent hours on the shop floor, observing how things worked, and talking to the operators, engineers, and quality control team. I noticed that a significant number of defects were related to human error, particularly during the assembly and testing stages. It seemed that operators were not following standard operating procedures, SOPs, consistently, leading to mistakes that made it past quality control. I called a meeting with the team to discuss these findings. What struck me was the lack of engagement and ownership among the operators. They seemed to be going through the motions, without a sense of responsibility for the quality of their work. I realized that we needed to create an environment where operators felt motivated to take pride in their work and were empowered to identify and rectify defects. We started by retraining operators on SOPs and providing them with real-time feedback on their performance. We also introduced a reward system that recognized and incentivized good quality work. Slowly but surely, I noticed a change in the operators' behavior. They began to take ownership of their work and started identifying and reporting defects proactively. However, I soon realized that our quality control process was also flawed. Inspectors were relying on random sampling, which meant that many defects were slipping through. We decided to adopt a more systematic approach, using statistical process control, SPC, to monitor and analyze data in real time. This enabled us to identify trends and take corrective action before defects occurred. As we continued to fine-tune our defect prevention strategy, I sensed that something was still amiss. We were still experiencing a high number of defects related to material quality. I decided to investigate further and discovered that our suppliers were not adhering to our quality standards. We renegotiated our contracts and worked closely with suppliers to implement quality control measures that met our standards. Throughout this journey, I was acutely aware of the moral implications of our actions. We were not just producing products, we were responsible for the safety and well-being of our customers. I made it clear to the team that defect prevention was not just about meeting quality targets, it was about upholding our values and reputation. It wasn't always easy. There were times when operators pushed back against the changes, and when suppliers resisted our demands for improved quality. But I knew that we were on the right path. I could see the pride and motivation growing among the operators, and the defects decreasing steadily. In the end, our efforts paid off. Defect rates plummeted, and customer satisfaction soared. We achieved operational excellence, not just because of our technical prowess, but because we had created a culture of ownership, motivation, and moral responsibility. Looking back, I realized that defect prevention is not just about techniques and tools, it's about understanding the intricacies of human behavior and the moral fabric of our organization. By addressing these underlying dynamics, we can create a culture of excellence that permeates every aspect of our operations. To achieve operational excellence through defect prevention techniques, it is essential to identify, analyze, and rectify defects in a systematic and proactive manner. This can be accomplished by implementing a robust defect management process that focuses on prevention, detection, and correction of defects throughout the entire product or service lifecycle. Firstly, it is crucial to define what constitutes a defect in the organization. A defect can be any failure or irregularity in the product or service that deviates from its intended design, specification, or customer expectations. Defects can occur at any stage of the product lifecycle, including design, development, production, testing, and delivery. To identify defects, the organization should establish a comprehensive defect detection process that includes multiple layers of checks and balances. This can include 1. Design reviews. Conduct regular design reviews to identify potential defects or flaws in the design phase. This can include peer reviews, technical reviews, and quality reviews. 2. Unit testing. Perform thorough unit testing to identify defects at the individual component level. This involves testing each component or module separately to ensure it meets the required specifications and standards. 3. Integration testing. Conduct integration testing to identify defects that arise when different components or modules are integrated. This involves testing the interactions between different components to ensure seamless functionality. 4. System testing. Perform system testing to identify defects at the system level. This involves testing the entire product or service to ensure it meets the required specifications, standards, and customer expectations. 5. Customer feedback. Collect customer feedback to identify defects or areas for improvement. This can be done through surveys, feedback forms, and customer complaints. Once defects are identified, they should be analyzed to determine their root cause. This can be done using various techniques, including 1. Root cause analysis, RCA conduct RCA, to identify the underlying causes of defects. This involves analyzing the defect, gathering data, and identifying the primary causes. 2. Fishbone diagrams. Use fishbone diagrams to identify the possible causes of defects. This involves brainstorming and organizing possible causes into categories. 3. Pareto analysis. Perform Pareto analysis to identify the most frequent defects. This involves analyzing defect data to identify the top 20% of defects that account for 80% of the problems. After identifying the root cause of defects, the organization should take corrective action to rectify them. This can include 1. Design changes. Implement design changes to prevent similar defects from occurring in the future. 2. Process improvements. Implement process improvements to reduce the likelihood of defects. This can include updating procedures, training employees, and improving quality control. 3. Employee training. Provide employee training to enhance skills and knowledge. This can include training on new technologies, tools, and methodologies. 4. Quality control. Implement quality control measures to detect defects earlier in the product lifecycle. This can include inspection, testing, and quality checks. To ensure operational excellence, the organization should establish a culture of continuous improvement. This can be achieved by 1. Establishing quality objectives. Establish quality objectives that align with the organization's overall goals and objectives. 2. Setting key performance indicators, KPIs. Set KPIs to measure defect rates, defect density, and customer satisfaction. 3. Continuously monitoring and reviewing. Continuously monitor and review defect data to identify areas for improvement. 4. Recognition and rewards. Recognize and reward employees for their contributions to defect prevention and quality improvement. 5. Collaboration and communication. Foster collaboration and communication across departments and teams to share knowledge, best practices, and lessons learned. By implementing these measures, the organization can prevent defects, reduce waste, and improve customer satisfaction, ultimately achieving operational excellence.